Welcome back to the next video in Unit 1. As you can see, now we're going to look at videos. So one thing to note, well, according to the syllabus, right, videos are actually no longer in the exam. However, both books do recommend learning about them quickly. And to be honest, well, I mean, yeah, I guess, well, of course, right, everyone is using YouTube, right? A lot of people are going to be, so I don't know, recording videos on their phone, etc. So I think, just learning about how videos work, right, learning about some of the details is, maybe quite interesting, right, quite relevant. Another thing, well, of course, okay, so like, of course, right, some people like doing the old exam papers. Now, if they try those, then of course they will see questions about videos. And I know a lot of people, well, they don't really like skipping out questions even on the old papers, because, well, I suppose, well, they want to calculate their real score, right? They don't want to skip, 25% of the paper. Right, so if we think then, well, videos, they're effectively just many pictures playing one after another. E.g., if a video is recorded at 30 FPS, and of course FPS meaning what, frames per second, then that means that 30 images will be shown per second, right? I.e., well, each image is therefore shown for 1/30th of a second. Right, there's going to be two types of videos. Well, one, interlaced, right? This is kind of the old style. Right, then progressive. I mean, yeah, this is what I would say like 99.9% of videos these days are going to use. So if we see progressive, this is going to show the whole video frame at once. So again, let's say we've got 30 FPS, and here, so here it's saying we've got 10 rows. So it's going to be showing, all of these 10 rows, right, each time, obviously, 30 times per second. No, well, of course, if you think, right, these are also going to have the columns, right, just to make the pixels. So it's going to be showing every pixel, right, every frame. In contrast, interlace, well, this is only going to show, well, let's say the odd lines or the odd rows, right, then it's going to show, well, the even lines or even rows. Right, and it's going to switch between them. So effectively, this is only showing half of the pixels on the screen, right, for each frame. Okay, so of course, let's say what frame 1 can show, say, the odds, right, frame 2, here, that can show the evens. Right, so old technology did this, and I mean, just have a think, right, why that might be. So if you probably thought, well, it's going to be due to hardware limitations. I think one reason given, right, possibly the old CRT screens. So, when I say CRT, right, that's cathode ray tube. Now, if people don't know, they're kind of those fat monitors. I'll try and draw the sort of side-on view. Something like this, right? So again, this is kind of side-on, right? I mean, here is actually the image coming out the front. Now, obviously, I guess now people are used to, the sort of thin LCD, LED screens. But right, these old CRTs, these were these big kind of like fat monitors. Now the way this works is, well, this would have an electron gun in the back, and actually you'll see this in, I think, Unit 3, right? Unit 3 is hardware. And what this would do is, well, basically, right, this would fire electrons, so if we say here, right, it's going to start on sort of row 1, column 1, right, then it's going to go across the column, right, it's going to go across the row, moving the electron gun. Right, then when it's done all of row 1, then it's going to fire the electrons onto row 2, right, then row 3. Now, probably this couldn't do this, say 30 or 60 times per second. That's going to be one reason they did interlaced, right, because, well, of course, then you only have to move the electron gun half as much. You're only showing half as much data. Right, but another issue was it's going to be the bandwidth, and to be honest, this was probably the more common reason. So to give an example, well, old TV stations had a choice, like, I guess it was the government, they said, well, if you're transmitting on this frequency, like, this is the amount of data you're able to send per second. Now, with this amount of data they were granted, and to be honest, again, this data, this data rate was probably limited by the hardware. So this data rate, well, either they could use 15 FPS progressive, right, or they could use 30 FPS interlaced. And of course, right, I mean, well, they're going to use the same amount of data because, well, what progressive is going to be sending the whole frame, right? Interlaced is only sending half the frame, right? Therefore, of course, well, we could have, a twice as high FPS, since we're only sending, half as much data, each frame. So what they found is that, well, the fact you were only sending, half of the rows at a time, or half of the pixels, right? I mean, that was actually barely noticeable because, I mean, the thing is, when humans see an image, like, that image actually gets kind of burned onto your retina for, like, I don't know, obviously some number of milliseconds. So actually, it's kind of like, okay, let's say if you like turn on a light really quickly, then turn it off. Like, if you do it quick enough, then the person won't even realize the light is switched on. Yeah, or I guess alternatively, right, if it's on, they won't even realize it's been switched off. Yeah, since it's too quick. Right, but what we can say, well, the higher FPS was actually going to be much more important for quality. So yeah, what they found is that using interlaced and having what a kind of double frame rate is going to be better than using progressive but having half a frame rate. Although of course, right, in these days, we don't really have this bandwidth concern. Yeah, therefore of course, yeah, I guess like in this case, of course we can use progressive, right, and a high frame rate. Yeah, that's not going to be a problem. So if we look at some of the video formats, and I mean most people probably recognize this image on the right. Of course, that's just going to be the YouTube kind of quality, video quality picker. Right, so it's going to start with the vertical resolution. So let's say here 2160. Right, then we're going to have either P or I. And if you notice all of these, okay, right, these are all going to be P, right? That means it's all progressive. Right, then they're going to have the frame rate. And if we see, the frame rate is often omitted, right, so it's kind of optional. Yeah, I think sometimes on YouTube they have it like I think sometimes I've seen like 60 here. Yeah, sometimes I've also seen 50 as well. And I think like maybe occasionally I've also seen I. So yeah, I think some rare times I've also seen them have interlaced as well. Probably for some of the old videos. Right, so yeah, these would be examples of some valid formats. Of course, 1080p progressive or 720 interlaced, and then 2160 progressive and 60 frames per second. Now, one thing to know, of course, right, this is going to be the vertical resolution. So if we say the vertical resolution, that's how many rows. Now, of course, I mean, there's also going to be the columns. Now, if we have 1080, I mean, usually that's going to be 1920. So of course, yeah, usually you're going to see 1920 columns, or 1920 width, right, by 1080 height. And again, yeah, so of course, right, if we look modern formats, are all going to be progressive. Alright, so if we try an actual calculation, so let's assume the following, right, the video format, 1920 by 1080, that's the resolution, right, the frame rate is going to be 60, and I guess, the format is progressive. Now, of course, if it was interlaced, we would just want to divide our answer by 2, but yeah, progressive, we don't have to do that. Right, then we're going to assume, I suppose, each image or each frame has a color depth of 32, so of course, that's saying that each pixel is going to be using 32 bits, right, to store each pixel. Right, and also assume no compression. So let's think, how many megabytes would each second of video consume? Now, even without seeing the formula for this, I mean, you should be able to sort of recognize how we can do this. Because if we said, if an image is just, if a video is just repeated images, to calculate the size of an image, it's just going to be the resolution, so 1920 by 1080. Right, then we're going to multiply by the bit rate. Right, the bit depth or color depth, and right, that's going to be 32 in this case. Right, then here, since we have 60 frames per second, right, then we just want to go times 60. So if you do that, of course, so I suppose, right, this is going to be the number of bits, right, per second. Right, then if we want to convert into megabytes, first we have to divide by 8, right, obviously, to get into bytes. Right, then we also need to divide by, let's say 2 to the power of 20, or again, as I've said in the other videos, that's also 1024 squared. Yeah, I mean, that's just equivalent to 2 to the 20. Right, so if you do all of that, then I guess, right, that should give us this, so 475, right, megabytes per second. Now, I mean, like, if you're familiar with any sort of video size, which, I think most people probably are, I mean, clearly this is clearly it's an unreasonable file size for 1 second of video, right? Which is why compression is so important. And sometimes videos can be compressed by 200 times or more, because if people are familiar, I mean, if you have a typical, like a 2-hour movie. Now, to be honest, I think most movies, if you're talking, I guess any sort of, like movie studio. I think usually they're recorded at like 24 FPS. I mean, maybe sometimes 30 FPS. 60 FPS is kind of unnecessary, to be honest. Because obviously the file size is going to be huge. But if you think like a typical 2-hour movie, maybe it's going to be, I don't know, like 2 gigabytes. Maybe up to sort of 5 gigabytes. So to have 475 megabytes for 1 second. Of course that's just going to be huge. Right, so let's say we're using the same video, right, so the same resolution, frame rate, right, same sampling not sampling resolution. well, I mean, all right, let's say bit depth or color depth. Right, so, okay, but now let's assume it can be compressed to 1/200th of its original size. Right, then we want to calculate the size of a 2-hour video, and again, write your answer in a suitable base. So let's just do the same calculation, right? So, of course, what's the resolution? Right, then we're going to times it by, well, the number of bits per pixel. Right, then we times it by the number of frames. So this is going to be what this is going to be the number of bits for 1 second. But then since we want 2 hours, well, first let's times by 60. Right, that's going to get us 1 minute. Then if we times by 60 again, well, that's going to get us 1 hour. Right, then if we times by 2, right, that's going to get us 2 hours. Then, like, I mean, to be honest, right, what you probably want to do, like, I guess you would just do this, okay, then you could sort of divide it by 8. So that's going to get us how many bits? Right, that's going to get us how many bytes? Right, then you would probably just want to, divide by 1024, of course, yeah, doing this on your calculator. Now, I mean, Kibbe, like, this is still probably going to be, like, millions or, like, hundreds of thousands. So, yeah, that's probably, like, an unreasonable base, really. Then you probably want to go, yeah, divide by 1024 again. Again, like, if that's something reasonable, I guess you can use that. Alright, if it's not, well, of course, you'd want to divide by 1024 again. And, of course, divided by 1024 once is going to be Kibbe, right? Divided by 1024 twice, maybe. And, yeah, 3 times is going to be Gibby. Now, to be honest, right, I think probably in this case, well, let's go 2 to the power of 30, which, of course, that's equivalent to, divided by 1024 3 times. And if we actually do that, okay, hang on, right, I think, yeah, alright. Okay, sorry, okay, right, this should be Gibby bytes, yeah, I forgot to change this. Right, if we do this calculation, right, it's going to be, 16.7 Gibby bytes. Now, guys, again, I mean, well, that video is just super short. Of course, videos are not on the syllabus, but yeah, again, right, maybe it's useful just to learn that. Now, if you've got any questions, well, just ask in the comments, and yeah, hopefully see you in the next video.